Okay, I want to get in this video a double angle formula for tangent. So I want to figure out tangent of 2 theta. So I've got a couple of options. So one option is that if I remember the sum formula for tangent, I can do exactly what we did with sine and cosine. I can just write 2 theta as theta plus theta and plug into that formula. My other option is that I can use the formulas we just derived for sine and cosine, and I can write this as sine of 2 theta over cosine of 2 theta. I actually like that option better. That's just a matter of personal preference. I have very few formulas involving tangent memorized, but I do know the basic formulas for sines and cosines. So, because I try to cut back on how much I need to memorize, I usually will go to writing things in terms of sines and cosines rather than having to remember other formulas. So I can say this is sine of 2 theta over cosine of 2 theta. Sine of 2 theta is 2 sine theta cosine theta. And I would recommend that you derive that from the sum formula once a day for the next week until you feel comfortable with it. Okay? And you either will accidentally memorize it or you'll get very quick at deriving it. Okay? Cosine of 2 theta, I've got 3 versions and I could use any of them. I'm going to go with the one that falls directly out of the sum formula, which was cosine squared minus sine squared. Okay. And then I've got this. This is a perfectly valid formula for tangent of 2 theta, but it's not the version that you're going to see in your textbook or in most textbooks. Most textbooks are going to give the double angle formula for tangent in terms of tangent. So, if I want to get to some tangents, I'm going to use the same trick here that I used when I was looking at the sum formula and the difference formula for tangent. I'm going to multiply by 1 in the form of the reciprocal of, cosine theta times cosine theta. So basically cosine squared theta. I could have written that as cosine squared theta if I wanted to. I chose to write it as cosine times cosine. Okay. All right. So if I do that, on top, I've got 2 sine theta cosine theta over cosine theta cosine theta. That's sort of why I wrote it as cosine times cosine rather than cosine squared. So I could sort of pair one up with the sine and one with the cosine. Okay. Down on the bottom, I think I'm going to switch to writing that as cosine squared. I do need to distribute it to each piece. So I'm going to get cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. So on top, the cosines cancel, and sine theta over cosine theta is just tangent of theta. So I get 2 tangent of theta. Over here, everything cancels, and that's just 1 minus sine squared over cosine squared is tangent squared theta. And if you used the sum formula for tangent and just plugged in theta for both A and B, this is exactly what you would get. Okay. So my formula, I'm just going to write it down over here. Tangent of 2 theta is 2 tan theta over 1 minus tan squared theta. And let's just practice using that. So I'm going to give us 2 problems to work on. So the first problem, let's find tangent of 2 theta, if tangent of theta is -3. And then the second question is let's find tangent of 2 theta if sine of theta is 1/4 and theta is in quadrant 2. So for the first problem, I gave you the tangent, so it's just a question of plugging in and simplifying. In the second problem, I gave you enough information to figure out tangent, but we've got to do a little bit of work to find it. Okay. Now, what I'm going to suggest you do is pause the video, try both of these problems, come back when you're done, and check your answer. We'll work through them together. Welcome back. So for question 1, I'm just saying tangent of 2 theta is 2 tan theta over 1 minus tan squared theta. And I'm just replacing all the tangent thetas with a negative 3. So that's 2 times a negative 3 over 1 minus a negative 3 squared. So that's going to be negative 6 over 1 minus 9. So negative 3 squared becomes positive 9, but I'm still subtracting that. So that's negative 6 over negative 8. The negatives will cancel, and that reduces to 3/4. Excellent. Not too bad. Okay. Now, for the second one, we do have to do a little bit more work because I didn't tell you what tangent of theta was. But I gave you enough information. So I told you we're working in quadrant 2. So there's my theta in quadrant 2. That's going to give me a reference angle of alpha. And I'm just going to create the right triangle that has alpha in it. Now, if sine of theta is 1/4, I know that sine of alpha is just the absolute value of 1/4, which is actually exactly the same because sine was positive in quadrant 2. So I can label the opposite side 1 and the hypotenuse 4. I'm going to want to get the adjacent side. So 1 squared plus a squared is equal to 4 squared. 1 plus a squared is 16. A squared is 15. A is positive the square root of 15. And again, it's positive because I'm solving for actual side lengths in the triangle with alpha in it, as opposed to signed side lengths. Okay. So then I can say tangent of theta, well, that's going to be my usual 2-step process. I'm in quadrant 2, so tangent is negative. And then I just attach tangent of the reference angle, which would be 1 over root 15. We'll want to rationalize, so I'll multiply by 1 in the form of root 15 over root 15. And that's going to give me negative root 15 over 15. Okay, so once I have that, now it's just a question of plugging into my formula. So tangent of 2 theta is 2 tan theta over 1 minus tan squared. So that's going to be 2 times negative root 15 over 15 all over 1 minus negative root 15 over 15 squared. So let's see, that's negative 2 root 15 over 15 on the top. Now on the bottom, that's going to be 1 minus. Now, when I square negative root 15, I'm just going to get 15 over 15 squared. Now, if I'm feeling slightly lazy, I can observe that 15 squared is 15 times 15, and one of those 15s is going to cancel with the 15 on top. So, I'm going to have negative 2 root 15 over 15 all over this 1 I'm going to write as 15 fifteenths minus 1 15th. So that's negative 2 root 15 over 15 all over 14 fifteenths. Now when I divide by a fraction, I'm just going to flip and multiply. So that's negative 2 root 15 over 15 times 15 over 14. Those 15s cancel. 2 goes into 14 7 times. Looks like I'm getting negative root 15 over 7. So that's how we can use the double angle formula for tangent.